Alright, so today I'm going to talk about the Sifive Unmatched board made by Sifive, which is a RISCV processor board. And I probably should talk about just things I think they should have done differently with the base of the board. And then I'm going to talk about some other things. Overall, and I know they're selling this as a development board, and it is quite an accomplishment to have made an ISA standard, which is basically like a language for the CPU, in 2010, and then now they're opening it up, and they have good intentions, it seems, and but even hardware-wise, so there's two parts I'm going to go to. One is just the hardware performance as it compares to a Raspberry Pi, and then the second thing is things I think they should have done when putting this thing together, because for the most part it is, at least as I see it, is pretty much unusable. So it can be used. The state my board is now is not usable. At least not without some work. So I guess I'll start with the stuff that I think what they should have done, or there's things that this board doesn't have that you would probably want. Now, it's not really a consumer board, but there's a huge from this getting to the desktop, I think there is a huge road that needs to be traveled. Now, the state that hardware is in for RISC-V, to start out with, I ordered this back in December and it arrived in June. I know there's a hardware shortage. Okay. The price was $630 or something like that, somewhere in the $600 range. And they do tell you it comes with 1.5 gigahertz. And when I was thinking about buying this thing, it was more or less, well, I've tried a Raspberry Pi, and 2 gigahertz. This is what I was thinking to myself. You can overclock it to 2 gigahertz, and starts out at 1.5 gigahertz, and it's not that bad. I mean, it's not, Raspberry Pi isn't snappy or anything, but it's usable. So, if I could run this thing with an NVMe, it might just, it's not going to be at the performance level of, my regular computers, but it's, it's gonna have some, or this is what I was thinking to myself, it's gonna have some reasonable speed given that it's got an NVMe. Turned out that wasn't really the case, and so when I finally got it and I assembled it and I got parts that they had recommended specifically for this board, even the form factor for this board, when I ran it, it took a long time to boot. I mean, it was like, I have a YouTube video for that. I'm not sure I ever was successful rebooting this board here. And the power supply they recommended was too large for at least the case that I had got for the form factor. And you buy stuff online, you don't really have an idea of what the dimensions are, but they basically specifically recommended one power supply, and it was too large to go in. Not everything was going to fit into the computer, so I had to pretty much treat it like a small board. And I did notice that they gave us these elevators here too, and in their kit. Now, when you think about building a computer, basically they've got the RAM soldered in for you. They have the CPU fans for you, and you don't have to actually place the CPU in the slot. And most people would think, well, all you gotta do is screw the board down into the the case, get a power supply, connect the wires, and get a hard disk, and you're done. And the hard disk would just be the NVMe that goes right here. It looks like a stick of gum. You slide it in, you screw it in the back. So basically, but since it didn't fit the board, I just gave up in the case. I just gave up on using the case, and an hour into, or a couple hours into it, and I said, I'm not doing this anymore. I just took it out and I ran this thing with the power supply next to it, just kind of sitting on these four legs. And it took a while to boot, so I was really anxious to get the NVMe running, and came to find out that basically you can't just boot to an NVMe, so it's the board doesn't have a BIOS. So because it doesn't have a BIOS, basically they somehow got the board to boot from the SD card area, and there's some pins over here that basically, right here, you decide whether it's basically already preset to boot to that card. And the instructions, at least that I was seeing in various like their getting started guide, they said, well, if you want to boot to an NVMe, you just change a file. I think it's extboot.conf, and have it point to the NVMe partition, which or drive, one of the partitions on the drive, and it should just boot. Well, that never really happened. I did make that change, and then the instructions weren't really clear. Well, do I have to make the change in Ubuntu? I tried Ubuntu, I tried SUSE, and I didn't want to try out the USB. There's a way you can connect a small USB cable that they provide on this end to a computer through a USB port. And then they do give instructions, although instructions in their user guide didn't work, but from some guy's blog did work to display what was coming up when you when it booted. So the strange thing about this is that this board is when you boot in, normally on every other, well, I've only used x86s, it'll give you a list of messages of what's going on as the kernel and the system's coming up in text. So this doesn't. You have to redirect it through some USB port. I finally decided to do that because it was, as soon as I put the NVMe on, it seemed like it wasn't booting consistently. And basically, what they say is there's a setting that it will try to boot to the NVMe first and then to the SD card. So I downloaded both a kit from SUSE and from Ubuntu and unzipped these things using XZ onto the NVMe drive, inserted it, tried to boot, nothing's happening. You just get a black screen. And with the one of the main points is that with the SD card in this, it doesn't perform nearly as well as just a Raspberry Pi does. Just to put it this way, so if Sifive wants to move into the desktop, this thing was sold for just the board itself. You still have to get a power supply for this thing. And if you want to have graphics, you have to get a graphics card. So we're really talking $400 more than and then the NVMe is going to cost you at least $50. So now we're well over $1,000, and you can get a Raspberry Pi kit for $150 and plug it into your big screen, and you're in. Now, Raspberry Pis can't. Well, there's some people have gotten NVMe's to work in Raspberry Pis, but it seems to be just as difficult to get an NVMe to work on a Raspberry Pi as it is on this Unmatched board. And So after being able to look at the console, and then I noticed like after 4 or 5 times I had taken the little disc out because I had to go over to my PC and try to edit the file, because at times it would boot, times it wouldn't boot, or I just didn't want to wait. It takes 2 minutes to get to the start screen, and the system wasn't very responsive. So it was like, okay, well, it'll be faster if I just stick my and then you put it back in, it doesn't snap into place. And after about 4 or 5 times of removing this little SD card, it would pop back out just immediately. So I tried using a binder clip to hold it in, and so what the deal is on, if I can even show, because we actually have a decent view, the way SD cards are supposed to work, right above my finger there are, it's hard to count, but maybe 8 or 9 or 7 little copper pins, I would say. These are data pins for SD cards. And at the bottom of an SD card, which I don't have handy, there's the same number of copper, and they're supposed to connect basically at that spot. That's what the click is supposed to do, is hold it in place. And I'm not the only person that had this. Someone else posted they had a broken click thing. So I finally got annoyed and made the mistake of trying to take the top off. And when I took the top off, one of these pins was dislodged, and I have it held there by Scotch tape, but it's such a small connection that whether I have the electrical connection point on this microscopic, is it a millimeter wide in width little pin, I'd probably not, and so it just never booted again after that, and I just don't want to bother with it. If this thing had a BIOS, this wouldn't matter. You can choose something else. I don't know how much it costs to put a BIOS chip on here. In general, my suggestion for the Sifive people is that they ship it with an NVMe, that it boots to an NVMe. You can boot into the NVMe, and it has actually, and they pick a distribution. Just pick a distribution that has some kind of bootloader configuration tool. I know SUSE has one. They have a partitioning tool too. Now, they did ship with gparted, but I couldn't figure out whether they're calling it an SDK. I'm going to call it a distribution with GCC and Make installed, with an LXFE desktop in the front. Not a lot of apps. One browser, Epiphany, which you might not like Epiphany. It's not the most popular one out there. Firefox should be able to work, I would think. And so you're stuck in a slow and responsive system with not a lot of apps and no really way to install things unless you're going to download from source. And I'm thinking to myself, downloading from source into that environment, which was just painfully slow to boot up. I wouldn't even try to ship a desktop. To me, based on my experiences here, I would say that 1.5 gigahertz on RISC-V is the equivalent of half that speed on x86. As far as the way your system actually responds, it's kind of like the way M1s and the Apple computers may have a certain set of specs, but they feel like they're performing faster than those specs are. The M1 or ARM processors seem to be matured in a different direction, where it has more responsiveness per gigahertz of speed in the CPU. It's kind of You know, I know it's quite an accomplishment. I've seen some of their talks, and they were trying to get things to go in there. They did have the AMD drivers working. I did get an AMD card. Tried to boot from that first. I was just wondering what was taking so long with it to go in. So it was working for a little while, but it was just not a platform I want to use. It I'm being very mild right now, but it really felt like it was a very old computer trying to use a very an operating system that was too new for the hardware. I've never actually, I don't think, with maybe a few exceptions, ever felt like I was behind a computer that was running this slow. Now, it may end up being better with an NVMe. There may be some people with NVMe success stories. There was a person with a helpful blog that had the instructions as to how you're to get to Ubuntu. They didn't work for me, and I suspect that basically after this pin connection broke, and it's a very fragile pin connection. I'm going to go in a little bit into Raspberry Pi. After that broke, I suspect that my card wasn't really reading the pins, or they weren't connecting right, or at one point, while trying to hold the SD card in both with the drive and the binder clip, I would look at the output from the console and it would be just garble, which kind of tells me that there was some issue with the card simply resting in the right place for these pin connections. Now on that subject, let's go back to the Raspberry Pi. I mean, you can get a full can of kit's $150. But you can get the board. You can get the board. I don't know. Let's just be. Let's give ourselves a white. I'm probably going to overstate the price. Let's say the board cost $100. I don't think it cost $100, but okay. Even if the board cost $100 for a Raspberry Pi, that's 1/6 the cost of this, and they managed to put on a Raspberry Pi. They managed to have a slot where you can put SD cards in that's actually reliable. This whole board relies on the fact that this part that's very fragile here, and it doesn't look like this when you first get it. There's a cover. Is not going to break. Being able to boot to anything else relies on a text file on that little SD card to be able to be configured right by the end user. There were times even when the thing did run, I would open up a file manager and it would just close. It would open up the web browser and look at it, and then it would take some time to load. It would finally load. So the graphics card I got was one of the ones they had recommended. It was in the Radeon 550 series, and it fit, right here. And it was just about as big as the board. The power supply is about as big as the board. They also soldered on some RAM, so I guess it's one, not replaceable. This is the RAM, but two, I mean, most boards do have a limit as to how much RAM they can take, but not necessarily replaceable should something happen to the RAM. These, I guess, are the kind of pins you get on a Pi, but I mean, at this stage, if you're looking at a desktop, why mess with that? I mean, basically, if I were them, I would ship it with an NVMe. If you're going to charge $630 anyway for this, chuck on a $50 NVMe and maybe allow the end users to have their choice of maybe 4 distributions. we're not dealing with a Raspberry Pi Foundation that is intertwined with Broadcom that wants to have their drivers load a certain way and therefore you're stuck kind of using the Raspberry distribution, the Raspberry Pi, which is my biggest criticism of the Pi, along with their choice to use an SD card as a booting medium because they're not as reliable as other types of hard disks. But which is why I don't try to do a lot with the Raspberry Pi, because the disks eventually break. And they take a while to back up, and they take a while to restore from a disk image, like half an hour or something, even on a good computer. So, I really would include an NVMe next time, and I would have at least 4 different choices of installs that they can have. I mean, it might take me half an hour, but for them, if they're developing a whole board, they should take the extra half hour to just image it and not leave it to something so fragile. And then if they are going to have one of these little things for SD cards, which that there, at least make it as durable as what's on the Raspberry Pi. I mean, if your whole system depends on that, then okay. I did like the fact that they have a power and a reset button right here on the board, so in case it doesn't fit in a case, you can do it single board. I'm not really calling for anything to be bigger. I thought it was a little cheesy. You had to buy your own lithium-ion battery, but whatever. I still haven't got my wireless card yet, but it doesn't matter now. So I have an extra power supply and NVMe sitting around. So basically, my general assessment of this is that at this stage, that for not a tenth of the price, but a sixth of the price, you can get a Raspberry Pi that has just as much performance out of it. Well, the architecture's opened and all that. Well, I mean, the only thing that really means is basically you're not going to pay a licensing fee to the people that have helped make RISC-V what it is, but you will pay a licensing fee for the ARM. But you can customize ARM chips as you can customize RISC-V chips. That is to say, you can make the chip be less featureful than for what is needed on a desktop, therefore less expensive and serve a purpose like inside a hard disk or a phone or whatever, and ARM does the same thing. I don't know if my suggestion that they have a BIOS is completely incompatible with this hardware structure. It would be much better to be able to choose in some outside utility that's burnt into some kind of ROM chip how to, I want to boot from this other thing rather than having it configured inside the only thing you can boot from. Then the way the software arrives, I do understand that a vast majority of users are on x86, and so basically what the distributions are going to end up doing is they're going to compile as much as they can under the architecture, do a check to see whether they have, they don't have broken packages or broken package sets, shall I say. Like, they don't try to ship a desktop in which some of the libraries that it depends on doesn't build, but it really would be nice to have an installer. Be able to stick a USB stick in and have it boot up, place the NVMe in it, choose to boot from the USB stick, install it on the NVMe, and have the installer, as it does its stuff, actually make the USB stick bootable and configure grub or whatever it's going to use to boot properly instead of And there was more than one, and some of the information I'd look up, one person would say, just change the U-boot config. Someone else would say, change the ext linux conf file to get it to boot this other thing. But you have to have this, this little SD card's your effectively your BIOS, and in some ways for booting. And that puts the end user in a much more difficult situation. There is always a danger that these SD cards will break. Sifive recommends you get another one, but they don't say, well, back this thing up immediately, make a copy immediately from one disk to the next before you start in case it breaks. I don't think that my SD card broke. They did recommend the good kinds and the more durable kinds, but still, they can break. I've seen it happen. Maybe I wasn't using A1 SanDisk cards, but I've seen them break on Raspberry Pis. Do some pretty unusual things. Now, there's just inherently there's some things that RISC-V, at least now, well, they didn't ship on their board. I'm not going to say that RISC-V doesn't have the capabilities. Maybe it does, maybe it doesn't. But there are some things that you're missing when you get a RISC-V board from a technical standpoint. For one, it doesn't have graphics built into the CPU, so you are stuck getting you're going to be in text mode via USB stick at some other running computer to see what's going on, or you have to get a graphics card. And right now with the shortage, there was like, these cards were in the $200 range. So you're forced to get a graphics card. You have no choice if you want to use a graphical user interface. Not that way with Intel, and I am going to say it doesn't seem like it's that way with ARM. I didn't have known the user Raspberry Pi has to go out and get a graphics card. The other thing is, and I'm not sure that ARM processors, the kind that are in Raspberry Pis, I don't think they have what's called virtualization technology, and I'm not so sure that necessarily something labeled that has to be in a processor for an emulator to work, or something like Box in the old days would run without, on Pentium, I think on Pentium 4s, you'd run an operating system inside the operating system. You didn't have to worry about allocating CPUs. You would just allocate megahertz, but still, it doesn't really have that kind of stuff. Now, of course, I think the Sifive people are saying, wow, we just got a board that actually has a lot of the stuff a desktop user would use, including USB and NVMe and, and a network cable, and they've made a lot of, progress, I'd say, in the last 11 years from when they started working on it, between academia and the company. But at the same time, it's really not there as a so if they want to compete, they have to provide processors that are going to be if 1.5 megahertz, and I'm not even sure if this was doing 1.5 megahertz out of the box, but if 1.5 megahertz was this speed, or gigahertz, sorry, they're going to need to ship with like 4 gigahertz, and then someone will say, okay, the reason why I got this is because it outperforms a Raspberry Pi. What's the reason why someone would get this? Is another subject to cover here. So right now the reason to get this is basically because it's unique. It's basically a novelty item. The second thing is that not a lot of software is going to run on this, which some people could see as a positive thing when it comes to security. You can say, well, this is a secure way to browse the web and all that. That's probably the only real selling point they have, but they aren't that far behind. A Raspberry Pi is not that much less secure as far as the obscurity of the architecture is concerned. When it comes, it's pretty self-apparent that malware writers go for the biggest target, which is Windows and x86. Linux on ARM is probably not that, there may be some malware for Linux on ARM, but certainly it's not as prevalent. On this, there probably isn't any, because there's hardly anybody using it. So you might chalk that up as being a good thing, but I mean, anyway, if you just had this sitting somewhere and all you did is bank on it, you might feel that you have a safer platform. I mean, all software has bugs in it, so certainly there could be some way that malware can get on a computer of this type. Obviously, it's just probably hasn't been looked into or developed for as much as twisted as that statement is. Thinks in terms of developers for malware is something that exists, but we all wish did not exist. They had a whole bunch of instructions in their guide about using this USB connection, and to be able to see what comes out of the boot up messages, basically. It's okay to have I'd rather just they would have an HDMI thing there. Who knows if they have that capability yet on this kind of platform. I wouldn't have boot options controlled by dip switches on the board, or at least shouldn't be a necessity. I mean, basically, I really think they need a BIOS, or they need to have a meaningful set of, when you look at some instructions and they say, dip switch it over to 1003 or something, on or off, it's kind of like you go, well, I'll try that if this graphics card doesn't work, Also, the size of the graphics cards was like half the size of this thing. And there's some weird things about their instructions, a couple small things. There was, they actually listed the part number for a lot of the parts that they recommended, and they had a small handful of parts they recommended for their board. And on the 500 gigabyte Samsung NVMe part recommendation, they called it a 550 instead of a 500. Not that big of a deal, but still. And at least on the form factor that I had, or the version of the mini ITX computer box that I had, this did fit. There was, I could put the screws in exactly the 4 spots, but for that power supply, no. Now, I'm not an expert on computer boxes, and it could be that I had bought a computer box that is the former rendition of what mini ITX is supposed to be, and the power supply should have fit, but I mean, it didn't fit, so I couldn't use that actually. And it wasn't the height of the power supply. It was more or less where was this going to actually, because the graphics card took up so much room, and the board took so much room, and what was left over wasn't going to work. So right now, my assessment for RISC-V in the desktop is no. Not even close. It's going to need to outperform Raspberry Pis by a significant amount for people to find it appealing. I'm not harping on the fact that, you know, software compiled for a RISC-V computer is not going to, you know, your choices for software to run a RISC-V computer is a lot less than other platforms at this stage. I'm not really harping on that, but even if you do get to the point where the board has some appeal because of its actual speed, or they get to the point where 1 megahertz on RISC is the same, 1.5 gigahertz on RISC is the same thing as 1.5 gigahertz on ARM, I would at that stage think, okay, well, this might be worth using, but they really want to make this more powerful than a Raspberry Pi. They want to have so you can pick what you want to boot into. They want to make, you don't want to make, give it a BIOS. You don't want to make the thing that it depends upon to be the very thing that could break very easily. I'm not the only one. It's just basically slide it in, slide it out, and after a while, the spring mechanism was so thin and fragile, it was ridiculous. Just give it an NVMe, and if they want to make their own Linux distribution and call it an SDK, that they can do that. But for God's sakes, my real suggestion is just pick a Linux distribution, install GCC and make, and don't call it an SDK. Or call, if you want to call it an SDK, fine, but also it's a distribution, and make sure you pick a mainstream distribution that's a partitioning tool and a tool that will make sure that you can change options on boot loading. I know SUSE's Yast has that. And finally, the instructions were either one or two things were happening. Either the instructions were unclear and inadequate for anything that I tried, or that by the time I got my NVMe in there, this little spring had broken enough to the point where it was never going to follow the configuration changes that I made on the SD card to get the NVMe to boot. What they should do is just boot it. You pick what you want to boot from. I realized that a lot that what I ended up paying for was basically them developing and open sourcing different pieces of this architecture, you know, the CPU processor. It does have a built-in MMC, but it didn't, or eMMC, or some kind of memory on the board, but it didn't have a way that you can just boot into that as a backup in case this thing broke. I mean, this little thing being the choice as to what you boot into is not ideal. So if RISC-V is ever going to make it on the desktop, the price needs to go way down, or the performance needs to go way up, and the features of the hardware itself has to go way up. Otherwise, it's just never going to even get there by any serious measure. That's just on hardware, and then you have software. I am glad there are people that are working on porting software over to the RISC-V platform. It's good work, but if I had to guess how long we are away from, I don't know. I mean, I don't know just how formidable it would be for them to quadruple their CPU megahertz in the next 5 years, or actually the next whatever. If it's just at hand, if they could have easily made this 4 gigahertz, I don't see why they didn't do it. If it's formidable and almost out of the range of possibility for them to get these things up to 4 gigahertz, then, you know, when will this arrive on the desktop? 5 years at least to even have a chance on Linux, and that would totally depend on Linux having a desktop. So those are my thoughts. And basically, it ran like something I would never develop on this board, so I wouldn't bother calling their software kit an SDK. And I guess they justified making their own distribution because they wanted to call it an SDK. But basically, it was a distribution that looked kind of cool on screen, but it is always good to pay attention to what people present in their presentations. And basically, in this case, the guys did their presentations on this board and the software running in it. They really literally did just about all anybody would ever do in one of these things. I would not try to spend time compiling a kernel on it, and I know NVMEs do provide a boost with performance, but relative to the Pi, again, the Pi feels like it's twice as fast as this thing. So SD cards are the low-end hard drives, but still it would take a ridiculous amount of time to read this booting mechanism. So not thrilled with this board at all. And even if it was running on an NVMe, it might feel like a computer on spinning Rust disks going about 2 gigahertz at best. So at this stage, I'm not going to say I wish I didn't buy this thing, but it's going to be unused. And it's going to be unused basically because I have a broken part. I've spent way too much time, and I could envision myself spending way too much time, even if I had a card that worked, just to get the NVMe to work. And I still think I would feel that it was vastly underperforming. So those are my thoughts on the RISCV platform.